Welcome to another chapter in civil engineering and architecture. This is Mr. Seward, and we are doing beam design, which is chapter 3.2.6. And we're going to be talking about beam design. And beams are designed to safely support design loads of a building. Beams are primarily designed for bending and shear. You also need to check beam deflection. Beams are going to be sized to minimize material because for building materials, cost is directly related to the amount of material that's being used. More material, that adds weight, that makes a higher cost. Designers typically attempt to reduce the weight of construction materials to reduce cost. Now, we've done the first two steps in the design of a building. We've established design loads, we've analyzed beams, and now we're going to start to go through selection of a primary member. You have to remember that you're going to provide adequate bending and shear strength at the least cost when you select the beam. The preliminary member has to then be evaluated to make sure that it's safe and that it is a serviceable design. When we design a beam, we design it for a couple of different behaviors. The first one is elastic behavior. That means that if you have a beam designed and it puts a stress on it, stress or strain on it of some sort, the material, when you remove that stress or strain, will return to its original shape when it's unloaded. Think of like a flatbed truck going down the road without anything on it. It has an arc or an arch to it. When they put the bulldozer or whatever material they might be putting on it, then that turns to flattening out, or it might even turn to a bow if they overload it. When you take the stuff off of it, unload that flatbed truck trailer, what happens is the elastic behavior takes over and it returns to having an arch. But if you actually take the load off and it doesn't return to the arch shape, that's called plastic behavior. And plastic behavior is when material retains some deformation when it's unloaded. So when we look at this little chart here, to the left of the stress point, the yield point right here, is the elastic region of that material, of this piece of steel. To the right is the plastic behavior of the material, and that will go until you reach the fracture point of the material. Structural members are designed to act elastically during the service life of a building. There are a couple different ways to go about calculating the stress and strain on beams. These two standard structural design methods are allowable strength design, which is ASD, and low resistance factor design, LRFD. And depending upon material, building codes, and standards, they may specify one method over another. In some cases, which is true for structural steel, the engineer generally chooses his preferred method of calculating these things. We're going to be using ASD as our structural design technique in our class. And in ASD, the maximum safe load is referred to as the nominal strength of a member. You're going to hear me mention that in following videos. The nominal strength is the internal load that causes yielding stress across the entire cross-section of the member. Allowable strength is the maximum internal force that can be induced in a member based on design loads. So our beams are going to be I-shaped. That's what they look like right over here on the right-hand side. They are I-shaped members, and they are excellent choices for beams. we will be looking at what are called wide flange beams. They are designated by the letter W. A beam example would be a W12 by 58. That's a designation. And what you'll find is that the W12 refers to the height of the beam. 12 is about 12 inches. And then 58 refers to its weight per foot. So this W12 by 58 beam is 12 inches tall, and it weighs 58 pounds per foot. So what we're going to be doing in the following videos is we're going to select beams based upon bending moment. Then we are going to calculate their shear strength, and we're going to calculate their deflection. And if the beam is within the parameters of the deflection calculations, it's going to be considered a usable beam. If it's not within the design standards, then we're going to revise our selection and we'll do some very minor calculations to check to see if that beam, the second beam, is selectable or is usable for the building. So you'll see that in the videos in steps numbers 1 through 7.